Hi students. Okay, in the last class we studied about the Newton's first law of motion. Okay, today we will continue with the Newton's second law of motion. Okay, let us see what is there in the second law of motion. Okay, now actually in the first law of motion, okay, we studied the definition of the motion. Okay, that is forces. What is the force actually? So the first law of motion gave the definition of force. That is, force is that physical quantity which changes or tends to change the state or rest or of a uniform motion in a straight line. Correct? Now the second law of motion will give the equation of the force. Sure? So let's see. Now before getting into the second law of motion, we have to study about the momentum. Now, what is momentum? Now look children, the momentum means something which you have to feel. Okay, we cannot see it. Okay, we cannot much explain also can be, but you can feel the momentum. How we can feel? Okay, suppose in a field, okay, if you are playing with playing cricket with a tennis ball. Now you know the tennis ball, the mass is very less. Okay, at that time if it hit on our body, you know that okay, it will not hurt us. Correct? Okay, but at the same time, okay, the ball is a season ball, that is a cricket ball. Okay, you know that okay, we must be very careful. Okay, because if it hit on us, okay, what will happen? It will hurt us. Now what is the difference here? Okay, now both are balls. Okay, but the difference is that you know that the tennis ball is having relatively very less mass. Okay, but the cricket ball is having a greater mass. That is, it is a season ball I am talking about. Okay, so due to that, okay, we will hurt. Understand? Okay, so that is there. That is means if the mass is more, the hurt is more. That what is hurt here means the momentum. So we feel hurt because of the momentum. Tennis ball is having less momentum. Okay, because okay, it is having less momentum. Now the season ball, that is a cricket ball, will hurt because it is having more momentum. Why? Because of its mass. You understand it. Now at the same time, okay, now a tennis ball, suppose if it is thrown with a great velocity, okay, great speed, okay, then what will happen? Okay, now if the speed or the acceleration of that tennis ball is greater, you know that at that time it will hurt us. Correct? But at the same time, a season ball, if it is of a fall-on body, okay, with a less speed, okay, then we know that it will not hurt us. So when the velocity is, now the mass is not a matter, now velocity is also a matter. Okay, so that is, if the velocity is increased, that time also, okay, the feeling of hurt is more. Okay, the velocity is less, the feeling of hurt is less. Understand? So that, okay, due to the velocity also, okay, we can hurt. Now hurt means what I told it is the momentum. So more the velocity is, more the momentum is. Correct? Okay, less the velocity is, less the momentum is. So we can say, now the many example is there, the truck. Now the truck is having a mass is very high, even though it is moving very slow. Okay, if it hit a person, it can kill that person. Correct? But at the same time, bullet which is coming out of a gun, which is having the mass is very less, but the speed is very high. So when it hit a person, that also can kill a person. So here the thing is that, so we can observe from this that okay, some impact is there, okay, by the mass and velocity. Understand? Velocity and mass having some impact. Okay, now how this impact is? Okay, that is, it appears to exert some quantity of importance. Okay, that combines the object's mass and its velocity. Understand? Mass and velocity. Okay, on such a property is called the momentum. That is also introduced by Newton. Understand? So that is some quantity, okay, which is the combination of this okay, mass and velocity is the momentum. Understand? So how the momentum is defined? Okay, momentum P of an object is defined as the product of mass and velocity. Sure? So P is equal to mass into velocity. Sure? So P is equal to mv. So the definition, nothing to do with the definition actually. Definition is just an equation, a formula. Understand? Nothing else is there. Then from the definition you won't be able to understand what actually the momentum is. In order to understand the momentum, you have to understand about that feeling of hurt. Understand? That only can explain you about the momentum. Understand? Otherwise, this momentum will be very difficult to understand. Getting? So what is momentum? Momentum means immediately you have to remember that the hurt. More the hurt is, more the momentum is. Now in order to get the more hurt, what must be? The velocity must be more, the mass must be more, understand, etc. like that. So in order to define momentum, it is the just product of mass and velocity. Now what are the units? Look. Momentum, while telling about, it is having both the direction as well as the magnitude. Why? Sure it is. If a quantity having both magnitude and direction, what it is called? It is called the vector quantity, correct? So momentum is a vector quantity. Now why momentum is a vector quantity? Because you know that P is equal to mv. What it is? P is equal to mv, correct? Now here you know that v is the velocity and mass is the m. Now the mass is a scalar quantity, so it is a scalar quantity, no direction. Now velocity is a vector quantity, so it is having direction, correct? So because of the velocity is having the vector quantity, p is also a vector quantity, very simple. Sure. So its direction is same as the direction of the velocity. Yes, it is correct. So the velocity, the direction of the velocity is the velocity of the momentum. Now what is the unit of momentum? Unit of momentum is, now mass is of, you know that the mass is of kilogram and velocity is of meter per second, correct? So the unit of momentum is kilogram meter per second. That's all. There is no some short word is not there for it. So the velocity of momentum is kilogram meter per second. Since the application of an unbalanced force brings a change in the velocity of the object, it is therefore clear that force is also produced the change of momentum. Yes. That is the, now here the momentum is also, because now in order to change the velocity, we have to apply the force. So because of the force, what can also change? The momentum can also change. So the application of the unbalanced force brings the change in velocity, so the change in momentum. Now let's go to the Newton's second law of motion. What is Newton's second law of motion? Newton's second law of motion states that rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Now we will break this statement. First of all, rate. In physics, what is rate means? Rate means upon time, correct? In physics, rate means upon time. Now change of momentum, whenever the change, now you studied earlier the change of velocity. What is change of velocity? Is final velocity minus initial velocity. Then rate of change of velocity means v minus u upon t. That is what the acceleration we studied about. Understand? Like that. Now the change of momentum means final momentum minus initial momentum, correct? Now let P2 be the final momentum and P1 be the initial momentum. So it is the change of momentum. Now change of momentum is P2 minus P1. Then what is the rate of change of momentum? Upon t, correct? Now what is this P2? Now if the final momentum means the mass is supposed to remain same. Sorry. So that mv is the final momentum minus initial momentum is mu, understand, upon t. Now here you can say that this m can be taken common out. So which we can say that which is equal to m into it is m into v minus u upon t. Now what is v minus u upon t is, you know that it is a, so you can write this as ma, understand, like that. Now just this much part is taken, it is the change of momentum. The entire thing is taken, it is the rate of change of momentum. So here the rate of change of momentum of an object is proportional. Now what is proportional? You know that A is directly proportional to B. Now proportional means if one quantity is increased, other quantity is also increased. Understand? Now rate of change of momentum means what it is? Ma it is. So F is force F is directly proportional to Ma. Understand? That means if the force is increased, the rate of change of momentum is also increased. That is the meaning of this. Now you know that in the lower class we studied that F is directly proportional to, you can change it as in a constant using. We can write F is equal to Kma, correct? F is equal to Kma. Okay, so where K is a constant, because whenever the proportionality is there, there is a proportionality constant. So that is what the Newton's second law of motion. Okay, now the derivation also you understand. We will see in the next slides. Okay, now here so what is the Newton's second law of motion? States that rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Obvious. Okay, this rate of change of momentum will be in which direction? It will be in the direction of the force. Okay. So here now suppose an object of mass m, I think you understand all this. Okay, now here instead of this, okay, change of momentum, instead of proportionality sign you can put equal sign. Okay, here you can put equal sign. Okay, so here the m is the moving along the straight line with an initial velocity u, and it is uniformly accelerated to the velocity v in time t by the application of the constant force, okay, F throughout the time t. The initial and final momentum of the object will be P1 mu and P2 mv respectively. So change in momentum. You understand it? Okay, that only I explained there. Now the rate of change of momentum, that is also you might have to understand. Now here this is of written as V minus u. V minus u is written as a. So that F is equal to Kmi. You might understand this. Okay, so here, okay, a means V minus u upon t. Sure? Okay, then okay, we will go to the SI unit of mass and acceleration. What it is? It is of a kilogram and meter per second square respectively. So the unit of force is so chosen that the value is constant. So K become 1. Okay, so that what we are here doing is actually here F is equal to, correct, Kma. Now we are going to consider a mass of 1 kg, okay, is producing, okay, a acceleration of 1 meter per second square. Sure, in this case, okay, what it is, the F is equal to, then F is equal to, okay, F is also will be 1, understand? So that K is equal to 1, understand? If K is equal to 1, okay, then F is equal to what it become? Ma. Understand? That is when a unit force is applied, the 1 kg of mass, okay, it will produce 1 meter per second square acceleration. Understand? So that what actually the K become? K become 1. So F is equal to ma. Sure, all of you? Because F is equal to ma. So this is the force equation. So F is equal to ma is equal to force equation. Okay, now the unit force is in kg, unit of force in force is a kg meter per second square. Okay, kg meter per second square. Okay, that is also known as a Newton. Okay, now whenever the n is small letter, you must have to understand that it is of a unit of force. If n is capital letter, you must have to understand that it is the scientist name Newton. It is like that we have to understand it. And it is having the symbol of n. Okay, so the second law of motion gives us the, okay, how we can find, okay, the force. That's why it is called the force equation. So F is equal to ma is the force equation. So second law of motion, okay, gives us the force equation. F is equal to ma. Understand? Okay, now this is having some application also. What is this application I'll tell you about? Okay, you know, in a day-to-day life, you know that, okay, whenever we have something which hit us, okay, we try to reduce the hurt. Okay, now actually in order to reduce the hurt, whatever we are doing is we are applying the second law of motion. Understand? That is here, okay, while taking the catch of a moving cricket ball, okay, you may see that the fielder in the ground gradually pulls his hands backward. Okay, the hands, okay, he takes the hands backward. But actually for that, what actually doing? Okay, many things he is doing that. Okay, one is of because of that, okay, he is increasing the speed. Sorry, time. Okay, as the time is increased, okay, in order the motion, okay, so that we can say that if the time is increased, obviously the acceleration will be decreased. Okay, at the same time, what also will decrease, because of that the force, that is the acceleration will be reduced. Okay, so increase the time during which the high velocity of that is velocity is also decreased, moving the decrease to 0. Thus the acceleration of the ball is decreased, and therefore the impact of catching the fast moving ball, okay, is also reduced. Understand? Okay, like that. Okay, so that the this fielder will not get hurt. Okay, otherwise obvious it is not possible to take catch directly. Okay, that's why okay sometimes the fielder okay leave the catch. Okay, at that time what the spectator he left the catch and like that. Okay, we never understand what actually the position he was standing with. Okay, sometimes it is not like that he can take it directly. Okay, he can take it directly. Okay, once the proper position he goes, then only he can take the okay catch properly. Okay, otherwise it will hurt him. Understand? Okay, that is the okay case of it. So today we studied all these things. I hope you understand it. Okay, first we studied about the momentum. What is the momentum? Momentum is the rate of, that is a product of mass into velocity. Then we studied the unit of mass momentum. Okay, that is of a kilogram meter per second. Understand? Momentum you must have to feel. Okay, you cannot understand it through the definition. Okay, so whenever the momentum is there, you must have to feel about the hurt, okay, which we are getting through the ball, okay, through the gun. Understand, like that. Okay, and the other is of the second law of motion. What is the second law of motion? Okay, that is the rate of change of momentum is directly proportional to the applied force and acts in the direction of the force. Correct? From that we derived the formula F is equal to ma, that is force equation. Okay, then we got the this unit of force, that is of a kilogram meter per second square. Okay, and it is also known as a Newton on behalf of the Sir Isaac Newton. Correct? So these are the things we studied here. Okay, you have to read the textbook properly, and also what you have to do is write down all these notes. Sure? Okay, for today this much is enough. Bye.